Assalamu alaikum wa rahmatullahi wa barakatuhu. Dear students, I hope you people are good by the grace, by the clemency of Almighty Allah. May Almighty Allah wrap you with His special boon. Last time we were talking about one of the important topics as far as carbon and its compounds are concerned. We were talking about isomers. Regarding the isomers, let me recapitulate what we discussed in the last video lecture, dear students. Last time, I told you, dear students, that these isomers are actually the organic compounds having the same molecular formula but different structures. Isomers. Isomers, dear students. So a layman will pose your question that what actually these isomers are. These isomers are actually the organic compounds having the same molecular formula but different structure, and we call those particular organic compounds as isomers, and they show the phenomenon of isomerism. So what's isomerism? This is actually the existence of two or more different organic compounds having the same molecular formula but different structures. We call those organic compounds that they show the phenomenon of isomerism. But remember one thing, dear students, I must clear you people that you people should remember one thing. Whenever you people will go through these isomers, isomerism is possible only with hydrocarbons having four or more than four carbon atoms. I mean to say isomerism is possible only with hydrocarbons having four or more carbon atoms. Mark my words, dear students. Isomerism is possible only with hydrocarbons having four or more carbon atoms, dear students. So somebody will pose your question. This is very important question here, very important question, that somebody will pose your question that why methane, ethane and propane, why these are not showing the phenomenon of, I can say, isomerism. I must tell you, dear students, that isomerism is possible only with hydrocarbons having four or more carbon atoms. Isomerism, mark my words, dear students, and jot it down. This is very important point. Somebody will pose your question that why can't methane, ethane and propane show a phenomenon of isomerism? Why we are not calling those as isomers? Why? What's the reason behind this, dear students? The only reason, the only funda behind this is that isomerism is possible only with hydrocarbons having four carbon atoms. Now question arises, why organic compounds having four carbon atoms show the phenomenon of isomerism, and why we call them as isomers? The question is, the big question arises here, because only then we can have two or more different arrangements of carbon atoms. No isomerism is possible in hydrocarbons containing one, two or three carbon atoms per molecule, because then only one arrangement of carbon atoms is possible. So that's why no isomerism is possible in methane, ethane and propane, because they contain only one, two or three carbon atoms, dear students, respectively. So it's a very important question, very important question, and this has been asked so many times in the examinations, that uh, isomerism, why can't methane, ethane and propane show phenomenon of isomerism? Because they contain only one, two or three carbon atoms. I told you people, dear students, that isomerism is possible only with hydrocarbons having four or more carbon atoms, because only then we can have two or more different arrangements of carbon atoms. So I think this is more clear to you now, dear students. Let me recapitulate this, what I said to you people, that dear students, somebody will pose your question that why there is no isomerism possible in case of methane, ethane and propane? You must answer in a jiffy that because they contain only 1, 2 or 3 carbon atoms respectively. So dear students, somebody will pose your question that why isomerism is not possible for methane, ethane and propane. You should answer that because they contain only one carbon. For example, this is methane, CH4, this is ethane, C2H6, this propane, C3H8. Somebody will pose your question why these three organic compounds don't show the phenomenon of isomerism, because no isomerism is possible in case of methane. This is methane, formula of a methane, dear students. This is a formula of a ethane. This is a formula of a propane, dear students. So dear students, I am discussing actually important points regarding these isomers, dear students. So somebody will pose your question that why there is no isomerism possible in case of this very compound, and this very compound. Because dear students, as far as these three organic compounds are concerned, like methane, ethane and propane, they contain only one. This methane contain one carbon atom, ethane contain two carbon atoms and propane contain three carbon atoms. So there is, I can say, it's not possible to have different arrangement of carbon atoms in case of methane, in case of ethane or in case of propane, dear students. So no isomerism is possible in hydrocarbons containing one carbon atom like methane, I can say organic compounds containing two carbon atoms like ethane, in organic compounds containing three carbon atoms like propane, dear students. So no isomerism is possible in hydrocarbons containing 1, 2 or 3 carbon atoms per molecule, dear students, because then only one arrangement of carbon atoms is possible. This important point, because only one arrangement of carbon atoms is possible. So in case of last time we discussed butane, C4H10. So two isomers of the compound butane, C4H10, are possible. We discussed it in the last video lecture, those two isomers, dear students. So isomerism is possible only with hydrocarbons having 4 or more carbon atoms, because only then we can have 2 or more different arrangements of carbon atoms. So isomerism is possible only with hydrocarbons having 4 like C4H10 or more carbon atoms, because only then and then only we can have 2 or more different arrangement of carbon atoms, dear students. Hope you people got it, dear students. So last time we discussed an example how many possible isomers of C4H10, that is butane, dear students. There are two possible isomers of butane. One is N-butane. We discussed this thing, dear students. I'm recapitulating what we discussed in the last video lecture. I'm making you people absolutely clear regarding these isomers. N-butane. N-butane means normal butane. That's as far as normal butane is concerned, all the 4 carbon atoms are joined in a continuous state chain like this. Like this. 1, 2, this is 3, this is 4 carbon atoms, dear students. How many hydrogens we have? We have 10 hydrogens like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dear students. So this isomer is known as N-butane. N-butane. N-butane is normal butane. N-butane is called as normal butane, dear students. Normal butane, somebody will pose your question, what do you mean by the normal butane? You should answer in a jiffy that all, as far as N-butane is concerned, all the 4 carbon atoms 4, C4. All the 4 carbon atoms are joined in a continuous chain. Look, it's a continuous chain of carbon atoms, dear students. That's why this is normal butane. Continuous chain to I can say to give the following structure as far as C4H10 is concerned, dear students. So this was actually the normal butane. We can make the condensed formula of this normal butane as well. Like this. This is CH3. This is CH2. This is CH2. This is CH3. Look, the formula of this butane is C4H10. Look, one carbon, second carbon, third carbon, fourth carbon, dear students. This is C4. Now H10, 3H, 2H5 plus 2, 7 plus 3, 10. This is a condensed formula of this and butane. This was actually the first isomer of this butane. The first isomer of butane is normal butane, in which all the 4 carbon atoms are joined in a continuous straight chain. Now the second is, look, second isomer of this butane is like this. This is CH3, CH, CH3, CH3, dear students. Let's open this formula. Or how many carbon atoms? As far as the second case is concerned, 3 carbon atoms, we can I can say put 3 carbon atoms in a straight chain, and the 4th carbon atom can be joined in a side chain to give another structure. That's why I told you people earlier that isomerism is possible only with hydrocarbons having 4 or more carbon atoms, because only then and then we can have 2 or more different arrangement of carbon atoms, dear students. Let's open this. For example, this is like this. CH3, it's like this, CH3, then C, here is H, another CH3, like this, 1, 2, here is 1 H, here is another CH3, it's like this. So open formula of this and butane. So what we did in the first case, we I can say put it all the 4 carbon atoms in a continuous straight chain. So as far as this very isomer is concerned, in the second case, 3 carbon atoms, we put them in a straight chain like this. 1, 2, 3. Another carbon is here. Another CH3 is here. And the 4th carbon atom, as far as this N-butane, as far as the isobutane is concerned, can be joined in a side chain to give another structure. That is, so this isomer is known as isobutane. The second isomer of butane is known as isobutane. So this is a second structure, and this second structure is known as isobutane. In this case, 3 carbon atoms can be put in a straight chain. This is 1 carbon, second carbon, third carbon. Another is below the straight chain. So in the second case, 3 carbon atoms can be put in a straight chain, and the 4th carbon atom can be joined in a side chain, to give another structure as far as this butane is concerned. So the second isomer of butane is known as isobutane, in which the 3 carbon atoms can be put in a straight chain, and the 4th carbon, so 4th carbon, 1, 2, 3, so 4th carbon can be joined in the side chain to give another structure. So that's why I told you people that these actually isomers, or actually the organic compounds, having the same molecular formula but different structures. So this was actually all about I can say isomers of butane. One is normal butane, another is isobutane, dear student. And some important points regarding these isomers. In the next video lecture, we are going to study examples. I can say the isomers, 3 isomers of pentene, that is C5H12. Let's discuss them in the next video lecture. Till then, stay safe, stay blessed, and may Almighty Allah bless you all. Thank you for watching this.